Turkey is further demonstrating its ambitions as a global defense industrial power with major strides in developing a next-generation fighter jet engine. This project is not only a symbol of technological independence but also an affirmation that the country aspires to stand on par with major European players in the military, aerospace field. Behind the splendor of a modern fighter jet lies a long and complex process taking place on the engine assembly line, the aircraft's most vital component. The fighter jet engine is often referred to as the heart of the aircraft, as all performance, speed, and maneuverability depend on the strength and reliability of this component. The process begins with the manufacture of key components such as the compressor, combustion chamber, and turbine. The compressor is responsible for sucking in and compressing air before it enters the combustion chamber. This is where the fuel is mixed and burned at very high temperatures, producing hot gases that then drive the turbine. One of the most challenging parts of the assembly line is the turbine. This component must be able to withstand extreme temperatures that can exceed the melting point of ordinary metals. Therefore, special materials such as nickel-based superalloys are used, designed to maintain strength at high temperatures. After the main components are assembled, the engine is equipped with a full digital control system, or FADIC. This system functions as the brain of the engine, automatically regulating performance based on flight conditions. FADIC optimizes fuel consumption, increases efficiency, and provides rapid response to pilot commands. In the next stage, the engine undergoes a series of intensive tests. The engines are installed in a specialized test facility that simulates extreme flight conditions, from supersonic speeds to drastic temperature changes. These tests aim to ensure the engine can operate safely and reliably in a variety of combat situations. Remarkably, modern assembly lines increasingly rely on digital technology and artificial intelligence. Data from every stage of production is collected and analyzed to improve efficiency and reduce the likelihood of errors. The concept of a digital twin is also used, creating a virtual model of the engine that allows engineers to monitor and test performance in real time, even before the engine is actually used. Beyond the technical aspects, these assembly lines also demonstrate exceptional teamwork. Engineers, technicians, and materials experts work together to ensure each engine meets the highest standards. Intensive training and years of experience are key to producing reliable fighter jet engines. Furthermore, safety is a top priority. Given the complexity and potential risks of the production process, each step is accompanied by strict safety procedures. This is crucial for protecting workers while maintaining the quality of the final product. Ultimately, the engines that roll off the assembly line are not simply the product of technology, but the result of dedication, innovation, and meticulous precision. The world's most powerful fighter jet engines are a symbol of human technological progress, and their assembly lines are where science and engineering combine to create true power. A look inside this assembly line provides a glimpse into the complex and impressive process behind a fighter jet. From raw materials to finished engines, every step reflects uncompromising quality standards. This is where the future of aerospace technology is shaped in sterile rooms filled with sophisticated machinery, in the hands of experts working tirelessly to achieve perfection. This program is closely related to Turkey's fifth-generation fighter jet project, known as the TFX or Khan. This aircraft is designed to replace the aging fleet and become the backbone of the Turkish Air Force in the future. However, the biggest challenge in the project is not just the aircraft design, but the ability to create an engine capable of delivering high thrust, fuel efficiency, and extreme maneuverability. In its development, Turkey relies on collaboration between national defense companies and high-tech research institutions. They focus on several key aspects: increasing the thrust-to-weight ratio, supercruise capability, supersonic flight without afterburners, and engine durability under severe combat conditions. A fighter jet engine assembly line is no ordinary factory. The environment is strictly controlled to maintain cleanliness, temperature, and humidity. Even small particles like dust can damage sensitive components. Technicians wear special suits to prevent contamination, while robots and automated machines work alongside humans to ensure each part is assembled with microscopic accuracy. Furthermore, materials technology is a key focus. Modern fighter jet engines require materials that can withstand extreme temperatures, even up to thousands of degrees Celsius. Turkey is developing special metal alloys and advanced manufacturing techniques like 3D printing to produce lighter, yet stronger components. These innovations not only improve performance, but also reduce production costs in the long run. Another advantage the company aims to achieve is a full-authority digital engine control FADEC system. This system allows the engine to operate at maximum efficiency automatically, while also responding quickly to changing flight conditions. With this technology, pilots can focus more on the mission without having to manually manage engine parameters. However, the journey to self-sufficiency is not easy. Turkey faces various challenges, ranging from limited experience in jet engine development to geopolitical barriers that affect access to certain technologies. Sanctions and export restrictions from other countries also temporarily slowed the project's progress. However, these conditions served as additional motivation to accelerate domestic technology development. Strategically, the success of this project would have significant implications. Turkey would not only be able to meet its own military needs, but also have the potential to become a defense technology exporter. The global market for fighter jets and jet engines is enormous, especially for countries seeking alternatives to traditional suppliers. With a homegrown engine, Turkey could offer a complete package without relying on third parties. Beyond military benefits, the project also stimulates economic growth and human resource development. Thousands of engineers, technicians, and researchers are involved in the program, creating a high-tech industrial ecosystem. The resulting knowledge transfer will have far-reaching impacts, including in civilian sectors such as commercial aviation and energy. If successful, the fighter jet engine, developed by Turkey, has the potential to be one of the most powerful in the world, both in terms of thrust and efficiency. This would place Turkey in an exclusive group of countries capable of producing fighter jet engines. Independently on achievement, only a handful of countries have achieved so far. Ultimately, this project is not just about creating a powerful engine, but also about establishing technological sovereignty. Turkey wants to ensure that its defense future is not determined by external forces. With significant investment, political will, and continued technological advancement, this move could be a significant turning point in the history of Turkey's aerospace industry. The world now awaits whether this ambitious ambition will be realized. If so, the global defense industry landscape will undergo significant changes, with Turkey becoming a key player to be reckoned with.